Hello everyone, this is day 18, question 2 of our Leetcode activity, minimum stack. So, design a stack that supports push, pop, top and retrieving the minimum element in constant time. Implement the minimum stack class, min stack class, such that min stack initializes the stack object, basically a constructor. Void push int value pushes the element value onto the stack. Okay, void pop int top int get min. So push, pop, top, these are the normal stack uh, functions or methods we already use. Push just pushes the value, pop pops the last value, top just gives us the top element value, and int get min. So this is the main thing which we have to focus right now. What it reduces the minimum element in the stack. You must implement a solution with O of one coin complexity for each function. Okay, so O of 1. So for get min, O of we have to perform it in O of 1, and also it is a stack. So we can of course do a vector implementation, but then we can't, without like just using one thing, we can't do it in O of 1. So when if you are thinking for get min, whenever they call get min, you just iterate through the whole stack or the whole array and find the minimum. That will not give us O of one time. O of one time is we have to almost pre-compute it. If you want to get minimum in O of one time, we must pre-compute it and have the answer ready always. So how we will do that? So we'll do that using two stacks. So we'll use two stacks. One is ST and one is MN. So this is our minimum stack and this is our ST stack. So this is the first of all, this is the template given by the lead code to solve this question. So ignore this. This is just a initializer, that is a what you can say. It's just a constructor. We can ignore this. This has no role in our solution. Main void push. So int value. What it will do? It will take a int value and push it down in our stack. So we will use the. This is kind of cheating, I know, but we'll use the inbuilt stack. We'll mainly focus on the getting this minimum value, and for the stack implementations, we'll just simply use the str stack. So void push. So what we will do, suppose we have pushed, we are going to push the values 2, the value 3, the value 5, the value 1. So this we are going to push. So what we'll do is, whenever push is called or pop push is called, we'll just push directly in our st stack. St stack will have no logic, it will just be pure simple push. But for our mn stack, what we will do is, if it is empty, we'll push directly. So if it is empty, we will push directly. Now whenever a new element is added to st, so wait, here also I need to do this, here also too. Okay, So now when we push here 2 or 3, we will compare the top element of mn and the new added element and push the minimum of 2. So what is the minimum of 2 and 3? 2. So we'll just simply push 2 here. So you can see then when we add 5, again 5 and 2, 2 is minimum. So we will simply push 2. Now we add 1. Now 1 and 2, 1 is minimum. So we simply add 1 here. So you can see logically the minimum stack is always storing the value that at this level what is the minimum value in our stack. So till this number 1 was the minimum value. So you understood push. How do we push? We simply push in st, and for mn we compare our i- current minimum value and the new added value. If the new added value is minimum, we push that, and if our current minimum is the minimum of 2, we just simply push our current minimum. So you can see the same logic, st dot push val, that is we are simply directly pushing the value in st. But for mn, if mn is empty, if it is empty, so there is nothing to check, so we directly push it. But if it is not empty, we push minimum of mn dot top, that is the current minimum, and the new value. Now st dot pop, for st dot pop, now here's the logic again. We pop from both, simply pop from both. Why? See, if I delete one from here, so I have to delete one from here. Basic why? Because this corresponding number was nothing but the minimum value till this number. So minimum value till 1. Now if 1 does not exist here, then having a corresponding number here makes no sense. So it is simply logical to simply pop from here and here both. Now if you want to return top, just return the top value of st, because this is our normal stack which we have, which is the actual stack. Mn is just what it is, just storing the minimum value till now. So we just return st dot top, and now our main which we had to focus was get minimum in o of 1. So o of 1 how? Just return mn dot top, because the top element of mn represents the minimum value till now. So we just return the top element of mn, which is o of 1 operation. So this is how we'll not, whenever we get called get minimum, we'll not traverse the whole array, the whole stack, get the minimum value and return. That will be of O of n. We want O of 1. So that is basically we are always pre-computing the minimum value till now. And whenever get minimum is called, we just return it O of 1. So this is how you can do using two stack. But we can also you do this using one stack. I can argue somewhat that at last this is also two stack, because we are using one stack, but we are using a pair instead of a integer value. So what we are doing is we declare a stack which takes an input a pair, a pair of integers, in which the first element will be our normal number. So what we are going to push, uh, 2, 3, 5, and 1. So now we will push, not just push one element but a pair. So first element will be the normal value which we are going to push. So if st.empty, so how we will do push? If it is empty, we'll just simply push value value. Why value value? Because nothing is here to compare. So first is the normal value and second is the minimum value. So what we have done, where we are using a second different stack to store the minimum, here in the same stack we used a pair. First is the stack value and second is the value which we are storing in mn, which was the minimum stack. So we have used a pair for it. Now again, when we push 3, so when we push 3, you can see that firstly 3 will be pushed in first, but in second value what will do, minimum of value and st dot top dot second, that is here st dot top is this pair and dot second is the second value of this pair, because this is the minimum na. So we will do 3 and 2 minimum, so in which 2 is minimum, so 2 will be added. So again 5, now 5 and 2 2, again 2 is minimum, 5 and 2 again 2 is minimum. Now lastly 1, so 1 and 2, 1 is minimum, so 1 will be added. So you can see 1 2 2 2 2 1 5 3 2 1, so here it was 1 5 3 2 and 1 2 2 2. So this is same implementation as this, but we just here you are using a pair and a one single stack to do it. So void is same. Now void directly pop this, because anyhow here also we are popping the both sides simultaneously. Here also you will pop the both sides simultaneously. If you want to return top, you will return st.top first, because top will return the top of stack, which is the first value, and minimum you will just return st.top second, because that is the second value. And in such a fashion you can solve this question, which is minimum stack, and implement the solutions with O of 1 time complexity. Thank you.